Hello, here is Costas, Sierra Victor 3, Oscar Romeo Alpha, and today we have a nice Tektronix type 190B constant amplitude signal generator in the shack, where I'm gonna try to repair this thing and possibly lightly modify it to make it even better, let's say. Now, the unit is in overall bad shape. The cabinet of the unit. So you have these things here, these scratches, very deep scratches here. You have a screw here which shouldn't exist there at that position. Very deep scratches there. Okay, so it's not the best condition. And if you can see from that side, the case is really scratchy here and very bad dent at this point, and even there, and at the top again more scratches, and at this side more scratches. However, the unit does work. Okay, it needs calibration, but it does work, and internally it's in perfect shape. Okay, it's just a little bit dusty. It was just a little bit dusty, and I have cleaned that internally, and I have lubricated all the controls, and it's really ready to go as far as concerned the lubrication and these things. But it needs alignment, of course. Now, those of you that already have this generator, you will immediately realize that this shouldn't be here. And I believe the original attenuator was never present into it, because the previous seller sold it with this modification here. It's actually a head with some switch, some kind of switch here. I'm going to show you the circuit later on, as I have reverse engineered it. So what he was doing, the previous owner was trying to make it work without the attenuator head. Okay, and he succeeded. It actually works. I can output a signal from that plug here, that PNC plug, and it does work. So the original unit should look like this, actually. So you have here the main unit, and then you have an attenuator which is connected with a cable and a thick plug into the main unit. As I said, mine didn't come with this attenuator, and instead it came with this circuit. Let me find the circuit. Just a moment. It came with this circuit, actually. With this circuit, okay, the top one. So what's inside that custom head? It's exactly this circuit. I'm not sure exactly how this circuit works, to be honest. Now there's a germanium diode here, which is connected through a switch to one of the terminals, the feedback terminals of the head. And there's another potentiometer here, which is connected at the other end at the output of the generator, and at the wiper 1K resistor, again through another switch. The S2 and S3 here is just a single dual pole, dual throat switch installed in the circuit, in the head, and he uses it as a single pole switch, and he outputs two lines there inside the unit. I'm not sure how this works, to be honest. So I'm trying to make this thing work again by building the original attenuator of Tektronix, and I have redrawn the schematic of the Tektronix, the full schematic, and emphasizing into this attenuator and the feedback unit here. It's just directly out of the datasheet, but I have included everything on a single page. So this is the way it's been done, and I think it might be better to explain how this thing actually works in that portion of the schematic in order to be able to understand better the modification that I'm gonna do. So basically you have the output signal coming from that line out of the oscillator, the VFO directly, and then it comes into this cable, and what's inside here, into this whole area here, it's actually inside the head, the remote head. So the signal comes to the remote head and it passes through the attenuator network and it outputs at the output port, at the BNC port of the head. But also a portion of the signal is sampled through this circuit here, the diodes, and a voltage is present at this capacitor, and then this voltage is fed back to two things. First, it's fed up to the V40, which is the first stage of the ALC network, and together with the output amplitude setting, it tries to correct the voltage applied to the anode of the V30, and so the amplitude out of V30. So this is the ALC loop here, but also this feedback signal from the diodes is fed into a vacuum tube voltmeter, and the later models had also this circuit included and connected directly to the grid of V50B. Okay. So this is basically a vacuum tube voltmeter, and by having these sampling diodes here, these detector diodes here, you are actually having an RF vacuum tube voltmeter. Okay, that's the deal here. So what I'm going to do now is to show you how you can use this circuit, how you can build a local head, not remote head, a head attached to the unit, and also make the unit better. Okay, so I have. Let's first mention here that the vacuum tube voltmeter here is all the time connected with these detector diodes at the output of the oscillator, okay, to correct its amplitude. And for the time being, we will ignore this this network here. And I had to say that from the beginning, before we start mentioning any modifications, the bad thing about this unit is mentioned in the datasheet on page 5 of the PDF, okay, on section 1.1, 1-1, and the bad thing about it is this table here. Now, my unit is the 190B unit, and it uses the 190B attenuator. So the problem here is that the attenuator setting affects the output impedance. Okay, so it affects the output impedance here. So if you have the attenuator setting to 10 volts peak to peak, then you have a zero output impedance. But if you have the attenuator in one of the ranges from 0.1 to 5 volts peak to peak, then the output impedance is 25. And the same goes if you have the 190A attenuator. You see that with the different settings of the attenuator, the output attenuator, the attenuator network, you have different output impedance. And that's really, really bad when you're trying to do different things and measure different things in the shack. So I'm going to tackle this thing and try to convert this unit into a 50 ohm or high impedance 1 mega ohm output impedance. Okay, so